Good morning, everybody. My name is Phuc. I am professor of the University of Information Technology, Vietnam National University, Ho Chi Minh City. Today, I will present chapter 14 about database design. This chapter will compare and contrast conventional files and model traditional databases. Define and give example of fields, records, file, and databases. Describe a modern data architecture that includes files, operational databases, data warehouse, personal databases, and workgroup databases. Compare the role of system analyst, database administrator, and data administrator as they relate to databases. Describe the architecture of a database management system. Describe how a relational database implements entities, attribute, and relationship from a logical data model. Transform a logical data model into a physical relational database schema. You see here is a files versus database. Up to the left you see a files system. You see a file is a collection of similar records, and files are unrelated to each other except in the code of an application program. And data storage is built around the applications that use the files. But you see toward the right of the slide, you see a database. A database is a collection of interrelated files. And you see records in one file or table are physically related to records in another file or table. And the applications are built around the interactive database. And you see a pro and cons of conventional files. I present pro first. Easy to design because of their single application focus. Excellent performance due to optimized organization for a single application. About the cons, harder to adapt to sharing across application. You see a lot of difficulty, harder to adapt to new requirements, and need to duplicate attributes in several files. Now I go to present pros and cons of databases. About pro, data independence from application increase adaptability and flexibility. Superior scalability, ability to share data across application. Less and control redundancy, total non-redundancy is not achievable. Now I present the cons. More complex than file technology, of course, because you have database. Somewhat slower performance. Investment in DBMS and database expert. You need the expertise about the database management. Need to adhere to design principle to realize benefits. Increase vulnerability due to consolidating data in a centralized database. Now I go to the fields. Field is a smaller unit of meaningful data to be stored in a database. And you know, I will discuss you before, you can use the attribute in, or maybe you can use the column. But now you see, in this lecture, I will use the field. The physical implementation of a data attributes. Remember, we have primary key. That is the field that unique identifies a record. Secondary key, it is a field that identifies a single record or a subset of related records. Foreign key is the field that points to records in a different file. And descriptive field, any non-key field. Now I go to records. Record is a collection of fields arranged in a predetermined format. You also have the fixed length record structures, or maybe you have the variable length record structure. About blocking factor is a number of logical records included in a single read or write operation. Now I go to files and table. File is the set of on occurrency of a given record structure. Table is the relational database equivalent to a file. And you have a types of conventional files and table. The first one is a master files. It means record relatively permanent true values may change. Transaction files record describe business events. Document files historical data for review without overhead of regenerating document. Archival file, master and transaction record that have been deleted. Table lookup files, relative static data that can be shared to maintain consistency. And audit files, special record or update to other files. Now let me go to continue file and tables. Previous file design methods require that the analyst specify precisely how the records in the database should be. I mean maybe sequence or maybe file set randomly. And database technology usually predetermines and or limit this. Trained database administrator may be given some control over organization, storage location, and asset method for performance tuning. Now let me go to data architecture. Data architecture, files and database are to be developed and used to store data. The file and or database technology to be used, and the administrative structure set up to manage the data resource. Now let me go to a modern data architecture. Data is stored in some combination of conventional files, operational database, it means database that support day-to-day operations, and transaction for an information system. We also call transactional database a data warehouse database that stores data extracted from an operational database. And you can analyze the historical data in data warehouse in order to support data mining and support decision making. You also have personal database or workgroup database that can sharing. A lot of people can use this database. Now I go to administrator. Data administrator is a database specialist responsible for data planning, definition, architecture, and management. And database administrator is a specialist responsible for database technology, database design, construction, security, backup, and recovery, and performance tuning. And of course, a database administrator will administer one or more databases. Now I go to database architecture. Database architecture, it means the database technology used to support data architecture. It includes the database engine, database utility, CIS case tool, and database development tools. And here is a typical DBMS architecture. DBMS, as you know, is special software used to create, accept, control, and manage a database. And the core of DBMS is a database engine. And they also has a data definition language, DDL, is a part of the engine used to physically define table, fields, and structural relationship. And they also have a data manipulation language, DML, that is the part of the engine used to create, read, update, and delete records in the database and navigate between different records in the database. And now you see you have some typical DBMS like Oracle, like SQL, like DB2, and so forth. Now let me go to relational database. Relational database, a database that implements store data in a series of two-dimensional tables that are related to one another via foreign keys. The physical data model is called a schema. The DDL and DML for a relational database is called sequence. Structure, query language, triggers, program embedded within a database that are automatically invoked by updates. Install procedure, program embedded within a database that can be called from an application program. This is a logical data model of a database. In next slide, I will show you how to convert this logical data model to physical data model. And you see here is a physical data model. And in this model, you have 4 tables. I mean customer table, I mean order tables, I mean order product table, and I mean product table. Now let me go to what is a good data model. A good data model is simple. I mean the data attributes that describe an entity should describe only that entity. A good data model is essentially non-redundant. Each data attribute exists in at most one entity, except for foreign keys. A good data model should be flexible and adaptable to future disks. And you know, G goals are achieved through database normalization. Now let me go to data normalization. In chapter 8, I already presented the database normalization. Let me give you an overview about and a review about database normalization. Database normalization is a logical entity or physical table in its inferred normal form. If there are no attributes that can have more than one value or for a single instant record. A logical entity or physical table is in second normal form if it is already in third normal form, and if the value of all known primary key attributes are dependent on the full primary key. An unlogical entity or physical table is in third normal form if it is already in second normal form, and if the value of all known primary key attributes are not dependent on other known primary key attributes. Now let me go to conventional file design. Output and input design typically completed first. Fundamental entities from data model design as master or transaction record. Master files are typical fixed length records. Associated entities from data model are joined into transaction records as variable length records. And file assets are organized, selected. Maybe screenshot, maybe index, maybe hash, maybe ANSAM and VSAM. And now I go to goals of database design. You know, a database should provide for efficient storage, update, and retrieval of data. A database should be reliable. The stored data should have a high integrity and promote user trust in that data. And the database should be adaptable and scalable to new and unforeseen requirements in application. And in this slide, you see a logical data model in third normal forms. In this figure, you have a table, you have the relation between tables, you have attribute of your name, and you don't have the data type of each field in every table. This is a logical data model. And now I go to database schema. Database schema, a model of blueprint representing the technical implementation of the database, also called a physical data model. A method for database design: review the logical data model, create a table for each entity, create fields for each attribute, create an index for each primary and secondary key, create an index for each subsetting criteria. Designate foreign keys for relationship. Define data types, sizes, non-settings, domains, and define for each attribute. Create or combine tables to implement subtype structures. Evaluate and specify differential integrity constraints. And this is a physical database schema. In this figure, you have a data type of X field and X tables. And now I go to database integrity. The first one is a key integrity. Every table should have a primary key. Domain integrity. Appropriate controls must be designed to ensure that no field takes on an inappropriate value. Referential integrity. The assurance that a foreign key value in one table has a matching primary key value in the related table. And in the next slide, you will see no restriction. Delete cascade, delete restrict, or delete set none. In this database schema with referential integrity constraint, you see DC, delete cascade. D not, or maybe I have DR, it means delete restrict. Now let me go to database distribution and replication. Data distribution analysis established with business location need asset to with logical data entities and attributes. You also have centralization. Entire database will be saved on a single server in one physical location. In horizontal distribution, also called partitioning, tables or rows assigned to different database server locations. And you see efficient asset and security because you have a many sites, saving your database. Cannot always be easily recombined for this management analysis. Now I go to vertical distribution, also called partitioning. Specific columns of table assigned to specific databases and servers. Similar advantages and disadvantages of horizontal. Replication, data duplicated in multiple locations. DBMS coordinate updates and synchronization of data. Performance and accessibility advantage, increasing complexity. Later, you will learn distributed database management, and you can understand a horizontal fragment and vertical fragments, or maybe hybrid fragments. Combine horizontal and vertical fragment together. And you will know how to distribute your database into many fragments and save the fragments in any size of your distributed database system. Thank you for your learning.